So our next session is going to be, our next speaker is going to be Harshit Prasad, who's a member of the community, has been at PyCons for 4 times, and this is his first time in person. So let's all welcome him with a big applause. Thank you.
All right. Hi, everyone. I hope everyone is doing well. So today I will be speaking on developing culture to write reliable and performance services at scale. So this talk will be mainly focused on basically how what is observability driven development and how you can establish such culture within your teams. Uh, yeah. So like also it will also covers like how observability plays a crucial role in a software development cycle. Yeah. So I think let's begin with it. Before proceeding forward, a bit introduction about me. So I've been working as a software engineer at Blinkit. I'm based in India. Blinkit is a quick commerce company which is focusing on delivering groceries and household items within minutes. Also, I've been tech speaker from few years. I've been like, this is my, as Fabio mentioned, this is my fourth PyCon and first PyCon in person. Apart from it, like I have contributed in open source like communities as well. Also, I have been part with the Google Summer of Code, which is a undergraduate open source programs by Google. Yeah, this is a bit about me. So, why? So the first question arises like, why do we write software? So technically, like we write software like basically to solve problems of the people, right? So there are like two types of software. One is like good software, and another is like bad software, let's say. So if particularly if your software is a good one, so let's say you build a product and that product makes a success in the market, eventually it will kind of increase the user engagement as well on your platform. Uh, User engagement once increases, that means that it will be profits for your company as well. Bad software implies like downtimes, loss to the business, etc. So uh, to clearly um, to navigate, let's say, to the good software, let's say your software receives a month like a huge amount of traffic, and you have to make sure like your systems are reliable. Uh, like you like this kind of throughput is very much high and must be handled smoothly to make sure like people are the user experience is quite good without any frustrations. So what happens actually is like sometimes things doesn't go planned. There can be sometimes surprises where in production your services can go down. This is the time when your engineering teams actually are debugging kind of the root cause for it. But the issue is once they try to understand the problem, things have gotten a bit worse, like it's too late, or the mean time to resolve that particular incident is quite not good, I would say. So to kind of bridge this kind of gap where the mean time can be reduced, this is where the like in the complex systems we can set up monitoring systems by using this observability driven development. So monitoring is not equivalent to the observability. So monitoring basically involves building of dashboards of all collective metrics, and you have some kind of alerting over it. So it's a kind of a dashboard which like that, like monitoring basically acts as a you know, basically tells you all the insights of your service, what it's doing, how much traffic it's receiving, and shows you the trend over the weeks, etc. But what happens like in case of distributed systems, there is uh, like sometimes things becomes very much difficult where it requires a deep insights like how my overall systems are performing. Like one service is doing some task A, some other service is doing task B. So this kind of thing, this is where the observability comes into the picture, where it decouples the whole architecture thing here. So in short, I would say in layman language, like observability is kind of a health fitness tracker, where it basically it gives your code, like for your code, basically it records the heartbeat, health metrics, and keeps the code of like the service code in top shape. So yeah, so like if there is like no observability, then there is no monitoring will exist for that. So yeah, so like to make services more reliable, these are the three kinds of pillars like metrics, logging, and trace events. Trace events I will be covering at the how application level things work, and like how these events can be helpful to analyze and make some decisions as per your organization business on its working, right? So what happens is like few companies, let's say like when we were also like working and when we were in very early stage, don't have like we usually didn't take these strategies or the practices as seriously. So due to this, it was like really bad, like it provided our users bad experience. Like if these kind of strategies are not followed, that means like either your promised SLAs between the client and the providers are breached, or you are just doing like your service performing very poorly as a trade-off and you are just okay with it. So this should not be the case. So these are the three pillars which I will be discussing. So I will be going like first through the basics a little bit, and then I will be deep diving into how things evolve, like what's the roles of each, and how later on, like once this kind of practice is followed, how you can help your team and build this culture within your team and help your peers to write reliable code. Okay. So let's first discuss it about logging. So logging basically helps in understanding the behavior of a service during the runtime. These are like everyone knows what's logging. So just I'm covering it a bit if someone doesn't know. But yeah, so it's a kind of a recorded piece of information which is flowing across the service. And mostly these are like a JSON structured, you would see. There are multiple levels of the logging. Like first, like you can see like debug, info, warning, and error. These have some their different roles. Apart from it, like the logs has this standardized attributes. Let's say like from which module, if you have a Python project, then from which module logs are getting generated, the timestamp at which the log was generated, process ID if there is needed, the etc. So these kinds of things are like can be simply initialized using a log client. Okay. So yeah. So this is, I think, one example where it's just a very simple, straightforward code where I'm showing the how logging is working with the JSON structure, and yeah, this is the I think this is the best practice to do these things in the JSON. I will cover later like why logs are like in JSON really helpful. Okay. So, but the problem is like, let's say you have a distributed system and you are getting a multiple request in your systems. Now, the thing is, it becomes very difficult. Let's say you got a issue, like in an issue tracker, you got like this user A is facing some kind of problems, and we have to debug it. Like the engineering team has to debug it. Now the issue is like it's very difficult to find that particular request of that user. So basically what we can do is like, this is just a naive example. So what we can introduce, there's a good practice of introducing the trace ID in the logs. So trace ID basically helps in actually giving more context. You can like filter out from thousands of millions of logs for that 1 million request, like for that one particular request, you can easily filter that request using this trace ID. You can see like the first request, you can see there is two types of errors. One is like the info log, and the other is the error log. So it was generated from the request one. You can see the trace ID is same for that. Similarly, for the second request, it's a different trace ID from the first one, but the context-wise, the things are almost same. All right. So this was a bit overview of logging, but the problem is like people misunderstood sometimes this thing. Like what they are like, oh, if the logging is solving the problem, then why we should not just log everything in the data? So the problem is like this is a kind of a limitation of logging, where like extensive logging can generate large volume of data, which can sometimes increase storage challenges, and also it's not optimal if you see it from the infra cost perspective. Also, like careless logging practice can also lead to some kind of sensitive information leakage, because sometimes if there are not well established culture within the team, or there are some, let's say, new developers, like let's say freshers, those are starting new in their career. So they are not aware of these things and can lead to sensitive information. Log noise, I guess it's the same thing, similar to the extensive logging. Sometimes log noise can be not helpful at all. Also, it does not provide the quantitative measurement of the system behavior. So what do we mean by quantitative measurement is basically your system which requires the resources to run on, like CPU, memory, etc. So for that, we use metrics. Yeah. Yeah. So for the metrics, um, so yeah. So first, let me cover what are the metrics. So the metrics basically actually define the quantitative measurement of the systems to understand how system is performing. It provides numerical and statistical data, which makes it easier to track the performance of the service is working, and detect anomalies if your service is not behaving properly. It also helps in the resource planning also, where you can plan, you can effectively do the resource planning of it to reduce the cost of your infra. Yeah, so these are like the 3-4 golden signals, like latency, traffic throughput, error rate, and the saturation. So basically, latency defines like how system is performing at the granular level, and how much requests are taking time to get processed. Traffic throughput is like, it's simple, the amount of traffic it's getting. Error rate is something like basically service not behaving properly, exceptions are being raised, and etc. So basically tells the anomalies, like the service is not working properly or something is bad going on, you can just fix. Saturation is like the your CPU memory percentage usage of your service, how much it's like using the resources. Are they within the limits defined, or do they need more resources? So here's like one walkthrough of like metrics. So this is a third-party tool called New Relic, where these metrics can be kind of collected. This is just an example I've taken from their website. I will show you like one code example of this. So let's say you basically you have a PyCon hall manager something. So this is kind of a tick, like just to see, you have an app to see like how many halls are booked, are they full or occupied. Yeah. So let's say I'm storing this kind of information in a cache. Just for sake of example, I've taken this thing. So what I can generally do is, if I want to know like if my program is being used by a lot of users, let's say in millions, what like this conference is having on a large scale, then what happens is like I want to know how many like the cache get and set calls, how much time it's taking for an average transaction call. So here, New Relic agent actually basically helps in doing the function tracing thing. And this is how like it will display as a metric in a breakdown table when the whole transaction can be observed. Yeah, so this is another second example where I am using statsd. So in the statsd also, where like it's doing the similar thing, but you can use statsd for other purposes also. It's not necessary you use just New Relic only. Both are similar, but you can use this thing. So you can see like this is just a basic example where I'm trying to calculate the latency of a particular piece of code, how much time it's taking. Yeah, so the limitations of metrics are also there as well. So the thing is like it kind of like when you are in a very heavily business driven organization, what happens is like these are just giving you insights about your systems on like the yeah, so like the logs and like how much your service is performing, etc. But it lacks few details, like only provides limited context. This is the only the like limited context only, and it the lack of detail. I mean, it lacks kind of business metrics mostly. Like let's say if you are in a e-commerce company and then you want to track like how much, what's the number of impressions products per page a user is seeing, or like how frequently the out of stocks are getting from the application, from your app. So these are the things. Sometimes like tracking too many metrics also can lead to information overload, which can make it difficult to focus on like what's important. And prioritizing and selecting the relevant and the crucial metrics is also important, which is also like implies to the over optimization. And yeah, this is the thing. So this is where like events come to the rescue. So these are not like, I would say these are the more focused on the application level events. Like, so these are fundamental components of the observability, but they kind of slightly provide a different purpose compared to logs and metrics. Like they can provide context rich information, as I said, like number of impressions or the number, like the frequency of the out of stock items, or something like, let's say you have built a cart checkout and you have to see how many users are getting checkout. So you can also add those events in your code. Yeah, so this is like all you can add metadata information, structured data, like timestamp, event types, identifiers, basically to identify what kind of event it was. And like the reason I'm saying this thing, because like usually in big companies, whenever like there's an incident, usually people ask for like what was the root cause and how much loss was due to that incident. So this is where events also come in helps in reconstructing the complete history of the system behavior, where you can see like if my particular metric was kind of disturbed and there was some production incident going on, these kinds of events can help me actually reconstruct the history, that what was the like what kind of business losses do I have faced, and yeah, so, and like what could be done better, what we can do, and like take decisions accordingly for that. So I think this is one example. Yeah, also in the events, I forgot to mention like this is like the events which I'm talking on. These are kind of more of analytical kind of events, where like since like users traffic will be too much, so you can't like store it in a very traditional relational database. You might have to use mostly databases designed for doing analytical purpose, like mostly the columnar databases like Cassandra, Amazon, Redshift, etc. So this is like one of the example which I've just, so this example is actually not using any columnar DB, but just a traditional relation database, just to, for the understanding purpose. Let's say there is table by where I will be showing the PyCon booking events, and this basically actually tells like, so let's say this application, I've created a PyCon booking system, and this has actions like order placed, order cancelled, ticket orders basically, and ticket, what would the what was the ticket type, like it was student one, professional, or hobbyist. So as you can see, so what happens is like, next if I will show you, so what happens is like, you can do this thing kind of things when you like, when your request is like user has requested something for thing, and you can just emit that event to the table, and that table can be later on can be used by your data analyst in your team to understand the data, the trend in that data and the behavior of like what's going on. So this is the application level of events which I was talking about, which are kind of crucial for again, I'm repeating again that this is kind of crucial for the organizations which are very heavily focused on the business. So this was a bit about like metrics, logging, and events. Now, how we can drive this kind of culture? So it's very much important, like to educate your team, like about how these kind of practices can be established, and how how you can basically create a culture where like you face very minimal downtimes. The frequency of downtimes is like very close to zero, not actual zero, but close to zero. Yeah. So first thing is, as I mentioned, educate the team. So it's really important to educate the team about the importance of the observability, and how it contributes on creating reliable and the maintainable systems. Also, you can like set clear goals for the observability within your team, because each team has some different role in the organization, and their requirements for the observability can differ accordingly. So tell them like what aspects of your systems do you want to monitor, what key metrics would we should monitor, and yeah, and tell them the importance of like how it's critical to make sure the service is up and running. So another thing is like use of right tools, standardize event formats. By standardizing event formats, what I mean, like I shown you in the events example where we are doing there's a PyCon events booking application, and it was emitting the right like the right set of events which we need to analyze. So it's important to standardize those events, because if we will not like if standardization will be not followed, then it can mess up our own data only. Also, like choosing right tools for basically visualization of that particular data, or like for the alerting analysis of the observability data, and like these tools should be encouraged within your team. These can be like the third-party tools, as I mentioned, or maybe you can use some open source tools as well, like Open Telemetry. Yeah. So also like yeah. So this is a second thing which I want to highlight. This is the most important thing where like basically like after resolving a production incident, generally there's a culture you have to establish where you have to write some root cause of that. So the root cause, like the RCA means the root cause analysis, where this kind of like these kind of conducting review, like conducting these kind of RCA reviews are like really helpful. It full of learning. It gives you insights about where the system gave you surprises, and also like this kind of report actually includes like what kind of failure did it happen, which component of the system failed, how it was supposed to work, and what would be the action items which can avoid this same thing happen in the future. Overall, like RCS like helps in understanding root causes and helps in identifying areas of improvement. Yeah, it's full of learning, like going through the RCS. Yeah. Uh, so at last, I think lead by example and celebrate success. So this is very much important as like if you are leading a team, demonstrate observability practice within your own code which you are writing, how you are establishing every monitoring dashboards or the setting up of the events, etc. Show them real life examples, share some engineering blogs with them, tell how these companies are doing. Then also create documentations for your team because creating documentations is also very necessary as a necessary resource which completely outlines your the system which is owned by the team and how each component working and how they can refer to that document whenever it's required, and it should be like very easy, should be very easy. Yeah, and like celebrate where the observability uh, practices has helped you in production incidents. Like you had, so like following good practices can also help you in reducing the downtimes, as I mentioned. The frequency can be really like can be lowered, and yeah. So I think like at the end, I would add one note. Remember that building an observability kind of culture is not easy. It takes some time and commitment to get to achieve that kind of level. And it's a kind of a continuous improvement and a teamwork also. Yeah, so this was my talk about. Thank you very much for this talk.
Thank you, Harshit.
Yeah.
That was a pleasure. I think we have time for one question, maybe. So, anyone has questions for Harshit? Oh, okay. Yes, one question.
Hi, Harshit. Great talk. I have a question where you said that sometimes you face a problem where you have overlogging,
Sorry, can you repeat?
where you have a problem of logging extensively more than what's required.
Mm-hmm.
So what will your solution be to cut down the logs, and what kinds of logs would you decide are not pertinent to your application?
Uh, yes, so I think so. So y- I would say this is a good question. Like you cannot log everything just because of cost purposes. Maybe what you can do is like maybe you can check whether this is actually helpful or not. Maybe you can do some code refactoring where you can reduce the number of logs, and you can basically re-architect something, like not re-architect, but basically you can redecide whether logging should be better, or you can use some other kind of tools. For example, for the events, as I told, like I can like if this kind of analytical uh, data, then you can push them in a column database kind of thing. And yeah, I hope this answers your question. Okay.
Perfect. Thank you so much. Thank you again.
Okay.